All right. This week we are dealing with transformations of functions. Last week, the end of the session, you had to learn about, or you just learn what the parent functions are. This week we're going to be using transformations, which are just basically shifts. How's the graph moving up? How's it moving to the left and right? And that kind of stuff. So if we have a parent function, and that's basically where you start with all of these functions, is you deal with parent functions. Now, if you were going to, like, for example, if I was going to do f of x here, and I'm using the absolute value function, turn on I need to put my marker on here. And I asked you to graph the absolute value function. So this is the parent function. And I said, okay, I want you to graph f of x plus 1. It's like, okay, what does the 1 do to the function? Well, basically, it's just going to move it up one place. If I asked you to do the same thing with a quadratic, f of x plus 1, it's going to shift the graph up one unit. That's the nice thing about math, is it doesn't matter what function you're dealing with. If I said, okay, what is f of x plus 1 here? It's going to shift this graph up one unit, and what it look like, it basically looks exactly the same as the old function. It's just shifted up one unit. Now, if we put the number inside the parentheses, so if I asked you to graph, let me get rid of this. If I asked you to graph something like f of x plus 1, well, that plus 1 is going to shift the graph left and right. Now, if it's a plus, it's going to shift it to the left one unit. So my graph would look exactly the same, except it shifted one over. Same thing here. If I did f of x plus 1, I'm going to shift my graph over one unit this direction. If it was x minus 1, so if I did f of x minus 1, it's going to shift it to the right one unit. So now, oops, this is a pretty bad graph there. So that's basically the whole concept of this week, is being able to take a function and shift it over. As long as you know what the parent function is, everything that we do to a function is exactly the same. I don't care if it's an absolute value, quadratic, cubic, a square root, a cube root. It always does the exact same thing. It's either going to shift it up or down. It's going to shift it left or right. So if we're going to be shifting graphs this week, it says the graphs of many functions are transformations of the graphs of very basic functions, and those are our parent functions. If we add a number to the function, all it's going to do is well, we could add or subtract. All it's going to do is it's just going to shift it up or down. That is all that's all adding a number does to a function, and it doesn't matter if it's a parent function or not. If we are going to take the number in the inside of the parenthesis, that's going to shift it to the left or right. So if we subtract c, that's going to move it to the right, or yeah, it's going to move it to the right. If we add c, it's going to move it to the left. It's basically the opposite of what you think is going to happen with that graph. So here are some of the vertical and horizontal shifts. If you add or subtract a number, it's going to shift the function up or down. If it's inside the parentheses, it's going to shift it to the left or right. That's all the shifting does to a graph. So now let's take a look at this week's practice problems. So I'm going to put the Desmos presentation in there. I gotta go to it. 1 second here. So we're looking at the same thing. Okay. So the first problem on this week's assessment, it just says use the graph of f of x equals x squared to write an equation for the function whose graph is shown. Okay, so it looks like this graph is being shifted down. So it looks like it's the parent function being shifted down 3 units. So all I'm going to do is I'm going to say, okay, my parent function is x squared. So now I'm just going to shift this graph down 3 units. So this is just going to be x squared minus 3. That's it. That's all we're doing this week. We're learning. We're just How is that graph being shifted? Is it being shifted to the left, to the right? Is it going to go up or down? Brian, any questions so far on what we're doing this week? Okay, let's take a look at the second problem on the practice for this week. Second problem, it says use the given graph, x to the third, to write an equation for the function whose graph is shown. Now, you have to remember that the graph of x to the third, the parent function, looks like this. It comes up like this. So now it's coming down the opposite direction. So right away, I know that this has to have a negative in front because it's just flipping it on the axis there. So I'm just going to put a negative in front. And then it looks like it's being shifted 1 unit up. So I'm just going to go plus 1 because it's shifted up 1 unit. So if I look down at the bottom, it looks like letter C being shifted up 1 unit and so I'm going to go with letter C for my, and unless I can't see this, yep, I'm going to go with letter C for that. All right, number 3. All right, so Brian, what would you get for an answer here? It says the graph of f of x equals the absolute value of x, so this is the parent function, okay? So what would your answer be for this problem? And you can just put in A, B, C, D, or E. That makes no difference. Letter E, the absolute value of x plus 2. I would agree with that 100% because all we're doing is we're just shifting that graph up 2 units. That's it. Good job. All right. On the next one, it says use the graph of the absolute value of x. Well, the parent function graph looks like this. So I know it's flipped over, so I know there's going to be a negative out in front. Okay, so I know that. And then it's being shifted to the right, and it's also being shifted down. So, okay, so let's deal with the right first. So that's going to give me x minus, it looks like it's being shifted 5 places to the right. And then it's going to be shifted down 1 unit. So this would be my equation of that. Now let's see if there is any one that looks like that. So I've got an x minus 5 plus 1, nope. Negative x, nope. Negative x minus 5 minus 1. I'm going to go with letter E again for that one. So in that problem, there are more things happening. It was flipped over, it was shifted to the right, and it was shifted down. But each one of those taken separately, you just keep, everything, in math, it's like, okay, so it's shifted to the right. So I know it's going to be a minus sign inside the parentheses or the absolute value. It's being shifted down 1, and then it's being flipped over. So that's going to put that minus sign on there. All right. This one, it says use the graph of the square root of x. Okay, so the square root of x just looks like this to write an equation of the function. Well, looks like all it is being shifted down, looks like 2 maybe? It's hard to tell. But this just looks like the square root of x minus 2 for my answer. It does look like letter D does give us that solution. All right. Brian, this one is for you. So this graph looks like it's just being shifted over. So what would your answer be for this problem? And I'm not even sure what number we're on anymore. There's not a lot of work to do in this week's practice. I mean, when you think about it, it's just being able to shift over left, right, up, and down. Letter A, y is equal to x minus 3 Does that say? That one's hard to read. Oof. I'm having a hard time reading A and B. Horizontal shift, vertical shift. Nah. Okay, I'll go with A also, because it's being horizontally shifted on the x-axis, x minus 3 to the third power. Okay, it's kind of hard to read some of those, but I would go with A. All right. Well, that was a little bit easier to read. Okay, in this problem, it says identify the parent function and transformation shown in the graph. Write an equation for the function shown in the graph. Okay, so this problem, the absolute or the parent function is definitely the absolute value function. Okay, that's my parent function. It's being shifted over 4 places to the right, so I'm just going to rewrite this as y is equal to the absolute value of x minus 4, nope, plus 4, and it's not being shifted up or down at all. So I'm just going to stick with this. So I've got the parent function is square root of x, and then y plus 4, the absolute value of y plus 4. So I'm going to go with I don't know what they mean by. I know it can't be that one. It's got to be letter. It's got to be letter D, doesn't it? But I'm not seeing a reflection in the x-axis, because the x-axis. Huh, I don't get what they mean there. Interesting. So it says identify the parent function and transformation shown. Write an equation for the function. Now, this is definitely our equation. I'm just not sure why they have it written out like this. So it looks like D is the only one that looks like that. So I'm going to go with D. I'm going to jump into our practice first. Make sure that they're not messing with our heads here, because that does look kind of weird how they have it written. So let me just check here. Check what number that is. Okay, so yep, it's D. Okay, kind of weird how they have that written. All right, next problem. So this is problem number. Let me go back to my thing. Number 8. Okay, number 8. It says describe how the graph of y is equal to x squared can be transformed to the graph of the given equation x plus 6 squared minus 9. Well, the x plus 6 is shifting it 6 places to the left, and the minus 9 is moving it down 9 units. So letter A, it says shift the graph of y is equal to x squared right 6 units. Nope. I'm thinking it's going to shift to the left. Shift the graph of y is equal to x squared down 6 units. No, it's going to shift down 9 units. Part C, shift the graph of y is equal to x squared up 6 units. That doesn't sound right. Letter D, shift the graph of y is equal to x squared left 6 units and then down 9 units. That one sounds perfect. So letter D should be correct. Yes. Had to get through all of them before I got to the right answer. All right. This one is yours. It says describe how to transform the graph of the basic function g of x into the graph of the given function f of x. So f of x is natural log of x minus 8 plus 7. So we don't even know what the natural log graph looks like. But it doesn't really matter, does it? We should be able to tell exactly what's happening there. Okay? So Brian, what is happening to that function? Letter D translates 8 units to the right, 7 units up. I would agree with that 100%. Very nice. As I said, there's not a lot of work to do on this week's practice. All right, let's see here. Given the equation of the function g whose graph is described, the graph of f of x equals the square root of x is shifted 4 units to the left, then the graph is shifted 6 units up. So they want us to figure out what the equation for that one is. So I know that my parent function for this one is the square root of x, and it says it shifted 4 units to the left. Well, that means I know that this has to be a plus 4, because that'll shift it to the left, and then the graph is shifted 6 units up, so I've got a plus 6 on the outside. So this has to be on the inside, this has to be on the outside. So I'm looking at x, the square root of x plus 4 plus 6. I'm going to go with the letter D for that answer. Yeah, we're getting a lot of D's in that for those answers. Okay, now the assessment, there's a problem that looks like this. And some kids last year had a difficult time with this. It says, given the graph of g of x below, okay, so that is the graph. They want you to graph g of x minus 2 plus 1, okay? So in this problem, you know, I'm looking at this and it's like, okay, we don't know, you know, g of x is my graph. What is this doing? Well, it's shifting the graph 2 places to the right. So shift 2 places to the right. And up 1. So how am I going to graph that? Well, I always just take the endpoints. It's like, okay, so I'm shifting 2 places to the right, so I move that 2 places to the right. I'll move this endpoint 2 places to the right. And I'm also moving it 1 place up. So I'm going to move it 1 place up, 1 place up. So this is going to be part of my answer. And then I'm going to move this 2 places to the right. So that goes over 2 places, that goes over 2 places, put up 1. So now I have this semicircle, and this is going to be moved over 2 places to the right and 1 up. So that's going to look like this. So my graph, and I should have used a different color so we can see it, but my graph should be the blue one. And that's the whole concept of this week, is do you understand what is happening to the graph? It doesn't matter what the graph looks like. You know, if they give us some crazy graph like g of x, it doesn't make a difference. If they wanted us to graph g of x minus 2 plus 1, okay, well, that's going to shift it 2 places to the right. It's also going to shift it up 1 place. So that was one of the problems last year that kids really struggled with. Then the rest of the problems, you're going to have to write an equation. So for example, let's just cross this off. How would you write an equation for this? Well, we know it's the parent function, so I know it's going to be f of x equals x squared. And then what's happening to this thing? Well, it's just being shifted down 3 units. So I would just put minus 3. Now, if they asked me to graph something, let's say it looks like this. Okay, well, again, it's f of x equals x squared. That's the parent function. Now it's going to be shifted over 3 units to the right. Well, that means I'm going to have x minus 3 squared, and then it's shifted up 1, 2, 3 units, so I'm going to put a plus 3 here. So you should be able to write an equation of a function really easily just by looking at how it's being shifted over left and right, up and down. That gives us all of the tools that we need in order to rewrite equations. This is a fairly easy week this week. I don't think too many students are going to struggle with that. Brian, any questions on that? All right, Brian, that is all I have for this week for you. Hopefully, I'll see you again next week, because next week is the last week before Thanksgiving break. Awesome. Gotta love that. All right, you have a great week, Brian. Get outside. It's beautiful out. I'm sitting out on the deck right now. Man, is it nice. Bye.